Semua orang boleh dengar.
Yep.
Right, thank you guys. So kita finish off ada 2 lecture. Okay. So this is lecture 6 will be followed by lecture 7 on the mechanical actuation, types of rotation. Yes.
Saya belum masuk.
Siapa
Untuk
nama?
attendance.
Siapa
Nurul
nama?
Fatimah Siha.
Okay, right. Saya tengok dulu
Okay, terima kasih doktor.
Okay. Okay. Alright. So dalam basic mechanical, basic mechatronic yang involve basic mechanical, of course yesterday we have seen hydraulic and pneumatic punya actuation, tengok macam mana elemen-elemen of control, dia punya actuator, dia punya valve, hydraulic and pneumatic system itself. Kita nampak basically this hydraulic and pneumatic the activate ataupun dia actuate mechanical motion. Okay, it can be linear, it can be rotary, it can be macam-macam. Alright. So the motion of in the mechanical system basically supporting this kind of actuation. Dia macam tengok JCB, dia ada dia punya arm yang boleh extend, boleh gerak. So there are motions basically involved lah dalam system of mechatronics. So ada banyak jenis motion yang kita boleh tengok secara umum. Yang paling common sekali adalah 3 jenis. Ini rotary to rotary motion. Contoh gear, belt dan juga pulley. Okay. There are rotary to translational, contohnya lead screw, rack and pinion, belt and pulley. And then number 3 we have cyclic motion. Alright, so dalam basic mechanical, basic mechatronic, kebanyakannya motion dalam sistem mechanical ni boleh dikategorikan pada 3 jenis motion. Okay, you can easily classify mechanical motion into these 3 types lah. Okay, dalam type of motion, basically you have motion of rigid bodies. It's a combination of translational and rotational. Okay, kinematics of rigid bodies. This is you belajar dalam dynamics. Then you have translational motion. Okay, 1 or more than 3 axes, and then you have rotational motion. So this is another general type of motion yang ada dalam the whole world of mechanical engineering basically. Cuma in this mechatronic kita cuma lihat 3 lah, iaitu rotary, more of a transmission motion, rotary translational and cyclic motion. Kita boleh dengar jelas suara saya. So kita alright, thank you. Kita biasa dengar degree of freedom kan. So motion of course untuk ke mana pun kita cerita, dia punya access kita still lagi kena simpan dan kena tahu lah. Alright, motion has to always go to the system coordinate x, y, z, at least 3D motion. Then you have rotation ataupun you have motion with respect to each direction, be it X or Y or Z. So in this case we have 3 degree of freedom contohnya. Okay, yes. This is degree of freedom thing. I will not go through this. This is robot. It's okay. So dalam konsep rotational space ataupun space punya motion, biasanya dia akan fall back to X, Y, Z punya coordinate, and then if you have more rotation than X, Y, Z, you can just add up to the number of degree of freedom. Kalau you ada barang ni memang dia boleh pusing in this 3 direction, dia punya motion is in this 3 direction only, then kita ada 3 degree of freedom. Kalau cuma ada one direction, contoh pada X direction, we have 1 degree of freedom. So basically dekat mana ada pergerakan to at a specific axis, basically you can classify that as 1 degree of freedom lah. Okay. This is the concept of loading dalam mechanical, of course, mechanics, the movement of masses, the movement of things, you nak transfer apa nama tu load ataupun you nak tahan certain load, loading you kena analyze. Alright, ini contoh macam sangat ni lah kan, sangat panjang cerita lah kan, but before basically you can move things, alright, because we are talking about moving object ke, we are talking about holding object ke, macam robot, macam robotic arm ke apa ke, dia mungkin nak kena angkat benda, dia mungkin nak kena lift, dia nak kena grip, dia nak kena pegang, dia nak kena pusing. So dalam setiap motion tu, dalam setiap I would say mechanical punya activities, motion ke, gripping ke, holding ke, swing ke apa benda ke, dia melibatkan loading. Maknanya you have to make sure that the mechanism or the mechanical part yang you establish tu dia boleh handle the load yang dia kena ambil lah. For example, kat sini kalau you ada macam gripper macam ni untuk di handle movement, these are the theories yang you kena ada in mind sebelum you boleh design sesuatu sistem mechatronics untuk handle certain amount of loading ataupun mechanical loading lah. Alright, macam sini. Finally, you know that from the calculation, the minimum torque required from vertical leg movement adalah 0.3 Newton meter. So you have to make sure that the whole structure ni boleh support at least 0.3 Newton meter. Dia punya motor ke, dia punya mechanical contact ke, kan. Dia punya macam-macam. I mean because we are talking about rotary to translational, cyclic motion. Semua ni melibatkan loading of mechanical. So because you are basically transferring motion. So every motion tu ada dia punya static friction ke, every motion tu ada dia punya momentum, ada dia punya inertia. Yang sistem mechanical tu kena boleh handle untuk transfer to the next bahagian lah in a way kan. Let's say kalau macam you buat satu gearbox, you punya gearbox tak boleh nak tampung motion ataupun load daripada receiver tu, then you punya gearbox akan fail dulu contohnya. Alright, so you punya gearbox tu mesti you design boleh handle motion ataupun mechanical energy daripada at least minimum yang you boleh terima lah. Maksudnya kalau you dapat torque daripada engine, saya cerita dalam konteks kereta lah, kalau the engine is producing macam 300 Newton meter of torque, for example, so gearbox tu kena boleh handle at least 300 Newton meter of torque untuk transfer kepada driving mechanism, tire ke apa benda kan. So gearbox kena boleh tahan that. So gearbox is kereta punya gearbox is part of rotation to rotation punya what they call that motion transfer medium. So dia sendiri pun kena ada loading analysis supaya you know that this gearbox actually boleh tahan berapa torque, boleh tahan berapa RPM contohnya. Alright. So benda ni adalah dalam konsep of loading yang you kena ambil tahu, kena kira, so that you know this gearbox, for example, boleh tak jadi medium of transfer for that kind of motion. Okay, untuk gearbox is rotational punya motion lah. Okay. So rotary to rotary motion mechanism, example gear, belt and pulley. So this is basically basic of gear lah. Okay. So dalam basic of gear, you ada torque, acceleration, alpha, velocity, omega, and displacement for input and output of gear. System parameters is number of teeth of the gear and radius, which give basically the gear punya ratio lah. Alright, so N dekat sini is you punya ratio. R is the radius, so N is basically number of teeth. Alright, kat sini you nampak you punya gearbox, you punya gear basically. So you have gear 1, gear 2, satu will be driving punya gear, satu lagi will be driven punya gear, and you have angular velocity, angular displacement. Okay, daripada driving side to the driven side. Alright, and dia punya ratio is basically you boleh ambil daripada sini radius ataupun dia punya number of teeth. So this is the very basic concept of the gear. Okay, the force yang penting sebab you nak kira dia punya force, so basically you must have some idea of macam mana nak dapatkan force acting dekat setiap teeth tu. So this is by design and by kira-kira lah. Alright. So, kalau you nampak gear ratio, you boleh ambil banyak benda tu to make up the gear ratio. You boleh ambil dia punya angular velocity, angular displacement. You boleh ambil dia punya radius of the disc itself or the gear disc itself. Of course, you boleh ambil dia punya number of teeth lah, number of tooth. Alright, this is the force acting. So from there, I think you boleh kira tu berapa number of force yang acted. And of course, this is by calculation of design. Again, you ada banyak lagi elemen-elemen lain yang kena ambil kira, macam material itself. Dia kena boleh tahan this kind of torsion ke, this kind of stress and strain lah, tu kira-kira lain pula lah. But that's the whole thing basically affect the design load yang sistem gear ni boleh ambil. Alright, so that's the very basic element of gear, how to get the gear ratio, macam mana kalau yang ni pusing berapa turn, yang ni boleh dapat berapa turn. So basically and these are the formula that govern the working principle of any gear system lah. Yang ini satu driving, satu driven. Of course, dalam keadaan benda ni tak ada slip, maknanya both gear rotates at the contact point. So you will have the radius and dia punya theta dia ni, input and output gear displacement, okay, will be sama lah. Maknanya dalam keadaan no slip, you punya radius and dia punya angle of rotation and displacement akan sama for both what they call that system. Okay, regardless of berapa you punya R yang you buat, dia sebab dia contact, maknanya no slip, dia benda ni akan sama lah. Okay, this is how you buat differentiation for both. Or last kali you will have something like this. Dia punya R and dia punya angular velocity. Gear ratio term, and this is the force. Again, last kali pokok mana pun kita nak tahu berapa force yang gear ni boleh ambil lah basically. Alright. Sebab angular velocity is something, number of gigi tu something yang basically define berapa RPM input, RPM output of any gear system. Tapi yang paling penting sekali adalah dia punya torque yang sistem tu boleh ambil, sistem tu boleh terima dan sistem tu boleh deliver basically, because gear ni bukan saja kita transfer rotation, bukan saja kita transfer RPM, kita transfer dia punya torque sekali. Okay, dan biasanya kalau based on this formulation, kita nampak kalau torque dengan RPM ni dia inverse. Okay. Kalau kat sini torque kita, kalau let's say for this gear kita punya RPM input rendah, kat sini RPM input tinggi, so biasanya torque dia akan berkurang. Okay, RPM dengan torque ni dia dia macam apa nama tu, inverse lah, dia tak berkala langsung. Okay. That's the thing. Alright, RPM, angular velocity and torque. Kita nak tahu kalau kita with this design, kalau kita bagi 10 Newton of torque, berapa yang akan keluar on the other side. Alright, sebab gear again bukan saja dia transfer rotation RPM, input and output, by the ratio, dia juga transfer kita punya torque, and this is how you get the torque lah. Alright. So on top of that, kita ada gear train. This is idler gear yang biasalah. Okay, satu pusing, satu lagi akan satu drive, satu driven. This is apa nama tu, gear train yang ada more than 2 gear lah. Kalau macam you ada gear ketiga, alright, and then you boleh observe dia punya rotation dia macam mana. Contoh kalau macam ni driving, okay, counterclockwise, yang driven akan jadi clockwise. Kalau you pakai gear train, you pakai more than 2 gear, yang driving clockwise, yang driven last sekali pun adalah clockwise. So depending on you punya design, you nak hasilnya lawan daripada arah yang driving ke ataupun ikut. So it's all up to you. Tapi yang penting sekali, again, when you go back to the theory, berapa RPM dia boleh transfer dan berapa torque yang dia boleh convert. Itu saja. That's all I think matters for gear lah. And then other than that, we have bevel gear, spur gear, worm gear, and helical gear. Different kind of gear for different kind of motion and dynamics yang kita nak buat lah. Next, we have ratchet and paw, also pakai gear juga. It's a tooth wheel. Biasa dalam kita punya spanner tu, kita biasa pakai konsep macam ni. Alright, ratchet and paw dia gear macam gini, ada paw untuk lock dia punya mekanisme. Biasa spanner lah aku pakai benda macam ni. Ataupun kita punya sprocket basikal pun ada juga. Kita boleh kayuh in one direction tapi in the other dia free kan, something like that. Okay, this is ratchet and paw. Then we have belt and chain drive, macam tadi jugalah. Okay, this is also power transfer, rotation to rotation. Selain daripada pakai gear, you boleh pakai belt lah basically. Alright, to do the transfer. Okay, dia kata kat sini, this is motor, it's a driving pulley. This is driven. Okay, this is driven pulley. In this example, the driver pulley is larger. Maksudnya kat sini lebih besar. The driven will run faster. Okay, depending on dia punya ratio dia lah. So, dekat sini satu pusingan, mungkin kat sini dah 20 pusingan. So, basically dia macam speed enhancer punya sistem. Okay. Type of belt, because this is the system basically run on belt. So, ada lain-lain jenis belt basically for different application. Ada belt yang ada gigi, ada flat, ada belt yang tak ada gigi. So you can read through dekat sini lah. Okay, ada yang flat, ada yang macam timing belt, you ada gigi macam ni. So it's different belting system for different application. And next, rotary to rotary, you ada chain, alright. Tapi dipakai sprocket system, tapi konsep dia sama macam gear tadi juga. You ada number of gigi, you ada number of R. From there you boleh kira dia punya torque transfer, dia punya RPM transfer, angular velocity, semua boleh kira. Alright, that's sprocket and chain. So that's the end of lecture 1, lecture 6. I'm going to lecture 7. Sekarang, you guys are still with me or you guys sambung tidur?
Ada doktor.
Ada doktor.
Okay. I'm sorry, this thing quite boring, but hold on. Okay. Now we have rotary to rotary. We have seen dia punya gear, dia punya bag and pulley and sprocket. Now we are looking at rotary to translation now. So in this case kita tak nampak dua benda bulat berpusing lah. So in this case satu rotary, satu benda bulat. Satu lagi is translational, benda yang bukan bulat lagi, alright. Mungkin benda panjang ke, benda dia punya motion of locus of motion dia is not round, alright. Example here we have lead screw, we have rack and pinion, and we have belt and pulley. Ini contoh lead screw lah, alright. Screw and nut, principle of a wedge to drive a nut. Low efficiency is sebab loss of friction dalam ni, because you have a lot of contact points. Then sometimes you have ball screw, okay, lead screw, ball screw, sama macam lead screw tapi sebab dia pakai ball bearing dalam ni, so things are much more better compared to lead screw terus. Alright, ada banyak loss lah sebenarnya kat sini. So this is maknanya kita pusing benda ni, kita pusing lead screw ni basically, and then kita akan menyebabkan bahagian sini ni akan going to left and right punya direction. Dia akan induce linear motion sebenarnya. Okay, screw ni basically dia akan buat cyclic motion, tapi material yang melekat dekat sini ni will basically move to left and right. So it's a linear motion. Rotational to linear motion. Alright. Sama juga dengan case rack and pinion, kita buat rotational pada shaft ni. Basically the rotational motion akan menyebabkan the whole mechanism to move from left to right. So again, rotational to linear motion. Yes. Then you have kat sini rack and pinion lah. Okay, sama juga rotational to linear motion. Macam tadi, macam rotational to rotational, you nampak satu gear transfer to another round object gear. Alright. Untuk rotational to translational, dia bukan round to round, dia round to rotational motion ke, for example in this case linear motion, left to right. Okay, dia tak menyebabkan pusingan lagi lah. And the last one, I think we have cyclic motion transmission. Okay, kat sini you have linkages and clamps lah yang as the effect of cyclic motion. So normally 1 degree of freedom, kinematically closed chain and robotic manipulator. The motion of one member ataupun output link of a linkage is periodic, function of motion of another linkage. So dia bersambung through link. Okay, yang biasa adalah slide crank mechanism or 4-bar mechanism. So this is slide crank yang nampak macam, contoh macam dalam kereta mainan kan. Alright, so satu bahagian ni akan pusing bulat, satunya akan experience some linear motion lah. Okay, ini contoh macam kereta api, ini contoh macam dalam kita punya combustion engine. This is the piston. Bila piston buat linear punya motion, kat sini akan ada cyclic punya motion. Now we are at cyclic motion. Dia berpusing secara periodic. This is 4-bar mechanism. Maknanya objek dekat bahagian sini bila you move dia punya link ni akan transfer and dia akan duplicate motion yang sebelah sini ni. Alright. Dipanggil 4-bar because basically you have 4-bar to achieve this motion lah. Kalau nampak dekat sini, I tak boleh nak run video, this is PDF. Kalau nampak dekat sini lebih kurang objek yang dekat sini dengan objek yang dekat sini ni benda yang sama. Okay, you assemble cara yang sama, tapi using 4-bar mechanism you boleh translate. Bila you bergerak kat sini, benda ni pun akan bergerak dengan dia punya join yang you dah decide. Alright. So next is cam dalam engine yang macam kita nampak lah, kita punya operational of combustion system. Kata kat sini, mechanical component of a machine use to transmit motion to another components called follower through a prescribed motion contact programmed by the direct contact. Alright. The cam mechanism consists of three elements: the cam, the follower, and the frame. Follow direct contact. Okay, so cam macam ni lah. This is di benda ni yang berpusing, and then sebabkan dia punya contact profile dia macam gini, dia menyebabkan linear motion kepada follower. Alright, so this is cyclic, this is rotational, and benda tu akan go back and forth in a cyclic manner. Okay, rotate mengikut profile cam itu. Okay, so cam ada banyak guna lah. Okay, this is pear-shaped cam. This is cam operated valve, alright. Banyak dalam kita punya engine kereta. This is also cam punya benda jugalah, alright. Biasanya dia pear-shaped. Kadang-kadang ada profile macam ni, bergantung kepada motion yang kita nak produce, bergantung kepada motion yang kita nak follower ni experience. And next we have bearings. Okay. Semua orang tahu kot bearing ni apa kan, benda-benda yang berpusing dan dalam dia ada ball. Okay, we call it ball bearing lah kan. Rotation, sliding, friction forces generate heat. Biasanya benda ni akan panas lah, because you ada friction between the ball and the surface housing material. This is plain journal bearing ataupun block punya bearing. Okay, so shaft masuk dalam tempat bulat ni bila dia rotate. That's the whole operation is all about lah. Then that's the concept of ball bearing. They support both axial and radial load. Maknanya bila you ada shaft, you sit on dia punya bearing, so dia punya loading dia adalah berbentuk radial, dan bila benda ni berbentuk axial, okay, maknanya berat whole system yang shaft ni pegang. Because shaft ni mungkin dia hold berat lain selain daripada berat shaft tu sendiri lah. Mungkin shaft ni pegang satu puli lagi ke, so puli tu punya berat dengan shaft ni punya berat semua resting atas ring yang pegang ball bearing. So actually the ball bearing is taking the whole load of axial load of the shaft bersama-sama dengan apa yang shaft tu pegang. Alright, so biasa kalau you all beli bearing, you all kena tengok axial load dan juga radial load ni lah. Alright, supaya you all tahu bearing you ni boleh ambil tak rotation motion yang dia diberi oleh shaft tu sendiri. That's the radial load, and of course that's the axial load, and of course bearing kena support radial load. Radial load ni maksudnya dia punya loading yang hasil daripada rotation motion lah. Alright, semua bearing mesti ada what they call that, mesti ada profile loading untuk axial dan juga radial. Some bearing macam roller bearing, tapered roller bearing, you bukan ada radial, you bukan ada axial, you ada moment, you ada apa lagi benda-benda lain lah. Okay, sebab of course macam this case, kalau shaft masuk dalam ni, shaft punya berat is resting secara axial, you ada rotational or radial punya loading kepada sistem. Okay, and of course pada masa yang sama, because this is roller and tapered, ada benda lain yang resting on the different axis of this one. Contohnya apa dia punya loading ni, saya lupa dah. Ada axial load, dia ada normal load, they call it normal loading. Maknanya loading, kalau shaft masuk tengah-tengah ni, bukan setakat berat shaft tu dia acted kepada axial punya this one, kepada resting load of the material to the ball bearing. Pada masa yang sama, ada normal load yang datang daripada material punya berat secara tegak kepada bearing, because this is tapered roller. Okey, bearing-bearing ni memang sangat biasa dijumpa dalam sistem gearbox lah sebenarnya. Alright, kalau siapa pernah ada experience dekat gearbox, these are the bearing yang ada dalam gearbox. Alright. Of course, this is ni tak ada apa. I think yeah, that's more or less the end of lecture 6 and lecture 7. Okay, last slide lagi is on the mechanical aspect of motor selection. Now this is masuk next punya topik. Okay guys, I think more or less kita cover